module which has two important topics that those topics are very important in order to make your business decisions or many decisions. So I'm just going to give you basic concepts and then we will solve those problems. So let me start with whiteboard here. I hope you can see whiteboard. So we are going to learn two things. Can you see my screen? Everything. In case if you don't, just okay. So first is AHP, which is known as analytical hierarchy process, and second is EVA, and this is called earned value analysis, and this is widely applicable in project management because you are manager, you are you have different projects, different products, market campaign, and different kind of projects or program, and you are there to manage those. And this technique is very helpful in order to make decision, in order to speed up projects and make the deadlines, manage the budget and all. So this is related to project management. And this AHP is related to multi-criteria decision making. Means you have multiple criterias and you need to choose the best. So we are going to learn first AHP. AHP. Actually, there are other techniques on the top. AHP, ANP, analytical network process. We have also another technique, fuzzy AHP. So, but we are just learning basic one so that you can develop the idea and later on you can learn this. It was developed in 1971, if I remember correctly, by name Mr. If I'm correct, Sati. This is the name. I will check, double. So what is here in AHP? First thing first, I think I need to check. Yeah, recording is going on. So first thing first, you need to have an objective. Let's say I have an objective to buy a car. I mean, I'm going to buy a car, or I'm going to select a CEO, or I'm going to select a job. I have multiple options. So this is applicable in multiple options. You have different cars available in the market and you want to select the best based on your requirement. Then you put the criteria. What are the criteria? Let's say you put the criteria, and criteria is like, first is style. You need a stylish car. Second criteria is reliability. Reliability, I'm not writing. Third is fuel efficiency or mileage, fuel. Oh, sorry, fuel efficiency. Three criteria, let's say. Now you have four cars, let's say in your mind. Car is made from Toyota, a car made from Ford, car made from, let's say, Chevrolet, and fourth, let's say you have a Volkswagen. And now, first thing first, you have these three things, which based on style, reliability, Toyota is very good in reliability, Ford is very good in style, um, uh, Volkswagen is very good in economy. Keeping all, how you can decide which one is best. So this is called hierarchy. This is the object. Then you have criteria. Based on these criteria, and then you have options. So these 3 layers, normally you can go further also, but it will be very complicated. There are softwares available in Excel, but it is paid, so we are not going to do. We are just going to do simple calculation. So 3 stages. Now so you have car, and then you have style, 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 and style. So, and then you are going to do this kind of thing. So hope you understand the first concept, what we are going to do. And this is called hierarchy. This is called hierarchy, hierarchy in organization. This is hierarchy. And this is analytical. Now I'm going to, first step of analytical hierarchy process is to make pairwise matrix. First step is to decide what is objective. First, to decide objective, criteria, and options. Second step is to use criteria, criteria, pairwise matrix. Criteria, and first step in this to make a pairwise matrix. What is pairwise matrix? Matrix. Those who are engineers or those who studied matrix, they know what is matrix in mathematics. So first thing first, this how you can develop this. It is, if you are doing a very expert work and things, the method is called Delphi. Delphi is nothing but an expert's opinion, in the field. Let's say you are going to do some you are going to launch a new car or new type of product. Then take their opinion of, top product leaders in the world or top product leader in the industry, those who can. So basically Delphi is opinion based, expert's opinion. Now here you are the expert. You can say, so here, this is the pairwise, how you can make pairwise matrix. I'm just going to, this is one. You keep only 2 at a time. Pair means 2. So let's say I'm going to do criteria. I have a style. And I have second thing is reliability here on this side. So this side is style and reliability pairwise. Same I can do for style and fuel efficiency. What is the meaning of one here? One is equal. One is style and reliability equally preferred. Here, 1, 3, 5, 7, 9. Here, same thing, 1, 3, 5, 7, 9. So this is a scale based on opinion. If I ask you, when you are going to buy a car, you prefer reliability or you prefer style, in compare to reliability or style. Let's say I'm interested. I say I prefer more reliability. What should be the weightage of reliability? How big is, in comparison of style, how many times you prefer reliability? I say, I prefer 5 times more reliability than style. Someone says here like 9, 7, 5, 3. Similarly, 3, 5, 7, 9. I've said fuel efficiency in style. I prefer style, or I prefer 7 times more style than, So basically, your interest is towards style. So this is a pairwise matrix that you can develop with the opinion, expert's opinion. Based on that, we are going to make matrix. Another simple thing, in other way, you can say Seattle. Seattle, 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 Se Seattle and Spokane. So Spokane is about, I'd say, 2,500,000, 250,000 people or census, and Seattle is about 750K. So Seattle is 3 times bigger. If I compare Seattle and Spokane, Seattle is 3 times bigger. Spokane is 1/3 of Seattle. So let me make, so second step to make the pairwise, how we make, I'm going to explain this. So let's make a pairwise matrix. So this is the third step. 1, 2. And here I go with style, reliability, and third thing I'm not writing, and fuel. Similarly, style, reliability, and fuel. This is style to style is same, reliability to reliability is same, fuel to fuel is same. Now you read in this way, you read in terms of row. So style to reliability is half preferred, is preferred half, or you can say half is 0.5. Style to fuel economy is preferred 3 times. Then, and so this side, now you check the reliability to style. So style to reliability is 0.5. Reliability is twice preferred over style. So you can say exactly the same, like Seattle to Spokane, Seattle and Spokane. It's 3 times bigger. This is 1/3 of Seattle. If I compare in pairwise, I can say Spokane is 1/3 of Seattle. I can say Seattle is 3 times bigger than the Spokane. Exactly the same. Reliability is twice preferred over style. Style is half preferred on reliability. Same thing here, fuel. So reliability and fuel. Reliability is preferred 4 times more than fuel. Now just reciprocal of this. Fuel to style, this is 3. Style to fuel is 3. Then fuel to style is 1/3 or 0.33, or this I can write 1/2, 1/2 or 0.5. Similarly here, what should be the value? Fuel to reliability, this is 4, this is 1/4. Now we have our pairwise matrix ready. So basically, you see the reciprocal value at each place. These diagonals are same. If you are clear about this, is it making sense to everyone? So this is first step. It can be based on the Delphi. It can be based on expert opinion. So this AHP is qualitative and quantitative method, mix of both. If this is clear, I'm going at the next step to show you the further calculation in Excel. So just a minute, let me share my screen then. So hope you can see my Excel part. Can you see my Excel? If you can see, then here you can see this is the same matrix I made here in Excel. Style to style 1, style reliability to reliability 1, fuel economy to fuel economy. Style to reliability half, style to fuel economy 3. So read in row direction, don't read in column direction. And now what we are going to do, we are going to normalize. The next step to normalize the matrix. How do we do the normalization? We take the sum of each row, each column, sorry. And similarly, I do this. Is it making sense? So I did this sum. Now I'm going to normalize this. How I can normalize? I just make this. So, and okay, I made this matrix. Now I'm going to do normalization. Normalization means the value of the column is 3.333. I would like to make it in 1. So how I can do? I can put the weight of each value. So 1 divided by 3.333. Okay, the same thing I do. 2 divided by uh, this. Similarly, I can do this divided by this. Similarly, I can do here this divided by the sum, individual values divided by the sum, and again 0.25 divided by this. Similarly, I do for the third column. This divided by 8. This divided by 8. And another thing, 1 divided by 8. Now I'm able to normalize. How I can check whether I have done the normalization? So I just take the sum of each column and let's see what is the value I'm getting. Okay, it is now I have converted into 1 or 100%. Now can you see this is the, now what I'm going to do, I'm going to take average of each column, each row, sorry. So now I'm going to take average of row. Sorry, here I have to write row average. And now I'm going to do equal to average. And then I'm going to take all of them. And then similarly, I'm going to do for all. Now I'm going to check whether this is also. And now you can see this is also normalized. Can you see, are you able to understand the value of this? So now I got the style is 32% preferred over this, reliability is 55% preferred, fuel economy is this. So reliability is most important, second is style, third is fuel economy. So now I got the criteria weight. These are also called eigenvector. Now, so we got this. Now the next step, to check whether we are doing a consistently this or not, consistency index, a consistency ratio. This is another step that we do, but most of the things are related to here. So if this is clear, means here you can get this value. Now I'm going on the, now we have to do multiply this A into, means we have to multiply this matrix with, so this is the criteria weight. So I just go here and I need to multiply this matrix with these numbers. So here, for simplification style, I'm just going to do 0.3 here, putting, and 0.6, 0.6, and here I'm just going to 0.1. These are the weight that I'm going to use because we got here. So just for now, we are going to multiply each of them here. So again, I'm just going to write, and now I'm going to see what is the value, 1, and then multiplied with this. Similarly, 2 and multiplied with this. Similarly, this multiplied with this. So I'm going to do in entire 0.5 multiplied with 0.6, 1 multiplied with this, mm, wait just a minute. So basically here you can see this is the A, which is can you see my slide part? This is the original matrix multiplying with this. Then we are getting this value, which is called AX. Then we have this lambda max. So just 2-3 minutes more and we are done. Now third time, 3, 4 multiplied with. And if you make a macro, it is very easy in Excel. So now we got AX multiplication of A and X value. Now we are going to do sum. Earlier we did average. Don't forget, here we are going to do sum. So equal to sum. And I'm going to take all these things together. And here we get the sum of all these three things. Do you get this value? And now again, I'm going to write this, the vector that we got. So here we got 0.3, 0.6, and 0.1. So when we did this sum, and these are our original priority vector, now we have almost our calculation done, just simple arithmetic we have to do. So here we got AX, which is 0.9, 1.6 point. Here we got lambda max equal to average of all three, average of all three. So how we are going to do? We are going to divide 0.9 with point this, 1.6 with this, and then we are going to do the average. So equal to this divided by this. Similarly, this divided by this. Similarly, this divided by this. And then we are going to do average. So we got, this is our lambda max. This is our lambda max. Let me make it smaller. Now we got the lambda max. Now we can see the consistency index and ratio very easily. So here they get 3.06. So lambda max, we got 3.05 because, and consistency index equal to lambda max minus n upon n minus 1. So we have three values, n means three criteria, and let's see how much we get here. So CI equal to, and so lambda max minus n, so this minus this minus 3 divided by 3 minus 1. Oh, something is wrong. Which is 3.06 minus 3 divided by 3.1. So let me do one more time. So 3.06 minus, I'm just going to follow the same divided by 2, which is CI equal to this much. Now we have to see consistency. So this is consistency index. Now we have to see this is a ratio which is based on the index that is given by the author. So for 3 variables, it is 0.58. So CR equal to consistency ratio is equal to CI divided by 0.58. If you see, so this is given 0.58, and that if the value is less than 10, value is less than 0.1, which is 10%, then we can say our work and our consistency ratio and this matrix and pairwise is perfectly all right. If this is making sense, I'm going to go further. So this is the formula CI, which is equal to CR equal to 0.03 divided by 0.58 from where we get, and then this is perfectly all right. So this our criteria that we have selected and their weightage we calculated are perfectly all right. Now question comes, which car we need to buy? So first we have done for only car. Now second thing we do for the style. So style, for style we compare all different cars together. Similarly, so Civic, Saturn, Escort, Miata, these are the 4 cars we have. So Civic to Civic, Saturn to Saturn, Escort, and they are same exactly. And this is exactly the same matrix. So if you are going to do for style, you are going to do reliability, and you are going to do fuel economy. So these are the priority vector for each of them, exactly the same method. And now, mileage, since mileage, we have already industry proven, or the company already claimed they have this kind of mileage. So normalize these mileage means 103 total. Then what is the weightage of Civic? What is the weightage of Saturn, Escort, and Miata? And total. So we normalized it, and now we have final result in order to compare and calculate and which one is going to be our best car based on the multi-criteria decision. So here, selecting a new car, style, reliability, fuel economy. And in style, Civic is 13%, Saturn is 24%, Escort is 0.07, Miata is 0.6, reliability, fuel economy. So this is a classic example. Now we are going to multiply. How we are going to multiply? I can give you one simple example here. So style, let's see the total value of Civic. So I multiply this with 0.3. I multiply with 0.6. I multiply this 0.1 because this is weighted average. And now you see, and so this is the total. And then I am going to multiply this plus 0.6 plus 0.1. Similarly, you do for rest 2 of them, and then you get these value. Overall, you can see now you have the right place to make the decision. Civic is overall 30%, Saturn is overall 27%, Escort is overall 8%, and this is 35%. And total, if you see, all of them is 100%. Now you have final decision. If you are going to buy, first option is Miata. The second option is Civic. Third option is Saturn, and fourth is Escort. So even you can make your decision. You can also prioritize which is the number 1, which is the number 2, which is the number 3, and which is the number 4. So this is the very important method that is widely used in order to select CEO of the organization. then go for the cost, and you can do the cost and other things. Now let's say this is one of the example, and Sati given, and these are the house. So a family of average income wanted to buy a house and identified 8 criteria that were important. So size, transportation, neighborhood. So this is the done by author. Now look into these and they selected house 1, 2, and 3. Now which house is going to be the best one? So first they did the pairwise comparison for criteria. This is the criteria, size is 17%. So finally they got eigenvector, priority vector, and these are the values. Now based on that, and lambda max consistency ratio should be less than 10%. If you are doing this work properly, means proper pairwise matrix, your consistency ratio will be less than 10%. And then you go for size and you compare all 3 houses together. You go for yard, you compare all 3. You go for all criteria and all 3 options. You do all different 8 metrics. Now finally you can see this is the home A is having 34%, home B is having 36%, and C is having 28%. Now it's very easy to make. First choice is home B, second is home A, third is home C. Similarly, this is the real work that has been done in USA. Which drink is consumed more in USA? An example of estimation using judgment: coffee, wine, tea, beer, sodas, milk, and water. And they did based on this criteria. So this is the pairwise matrix. And now this is the reality. So you can see the derived scale based on the judgment matrix is this. Means based on this judgment, sorry, I have to make. And now if you can see my screen, so look into that. This is the based on the pairwise matrix, and this is the actual from the US census or US statistics sources, that in USA 18% people drink coffee, which is coming close by this. Wine is about this much percent, which is tea is about 40, 42. Beer is almost 12, 11.6, sodas. And so this is the judgmental matrix or pairwise matrix, and this is the actual statistics result. They are very close to each other. So this is the importance. I hope you understand this method. This is interesting method if you are stuck in different. So now, I mean, this is just my old example. Who will be the CEO of your company and why? So Mr. Clinton, Margaret Thatcher, and George Bush. Margaret Thatcher was ex-UK Prime Minister. So we have, based on that, you can decide. So this is AHP. If you understand AHP, any question related to AHP? No question? Okay, then I'm going on the next part, which is called earned value analysis. And I think many of you are working on Microsoft project. You are managing your projects using Microsoft project, MS project. And on the top of this is called earned value analysis. What is earned value analysis? So basically it is based on the 3 numbers. And 3 numbers, which is these these are the three important items that you need to look. Planned value. So basically every project or every task has a plan, that how much time it is required, when, in 1 week, how much it will be done, 2 week, how much it will be done, and so on and so forth. So that is the planned value. Actual cost, after 1 week, how much money is actually spent. So this is a planning one. This is actually observation. After 1 week, how much money is spent, how much cost is occurred. And earned value, after 1 week, what is the actual value you earn, or you get the value of the work. So these three numbers are very important in order to do this. So planned value, and this is known as like this, actual cost and earned value. Once you understand these three numbers of any project, you will be able to make very good decision, and you will be able to manage project properly. And those who are doing PMI and other certification, this is one of the important thing. Now look into this. So this is a Gantt chart, and earned value, for example, as of today, this is very helpful to monitor your project progress at any point of time. Any point of time. Let's say it is going today, you decided you want to see the performance of the project, how it is going. You can do it exactly. So basically, by today, you just make the line. Okay, you want to do it today. What is actually activity A should be done by this time, which is totally done. Activity B should be done by this time, which is 80% done. Activity C should be done by this time, about 80%, which is only 70% done. Activity D should be completed by this time, 15%, which is not started yet. And Microsoft project, you can have all these information with very critical and detailed. So what is the actual planned value this time? As of plan, this is 18, this is 10, which should be done, completed as per planning. This should be a 70 of this, 80 of this, which is 16, and this should be 15 of 40, which is 6. So basically this was actually planning. Actual planned value was 50. As per planning, it was. Now, what is the earned value? As of now, you got 18 out of 18 here. You got 80% of this 10, which is 8. You got 70% of 20, which is 14, and you have not started yet the fourth activity, which is 0. And the total is, so far you actually planned 50, actually you earned 40. And now look into that. This you can get actual money spent or actual cost spent so far, which is 45. From the project tracking, from the budget, from the spending, that 45. So this, all three numbers. Now you can do all the calculations. So earned value, planned value. I'm just going directly on the question, which is, let's say a lemonade task. Make 1,000 cups over 50 days. So 1,000 cups over 50 days, that means how many cups per day? 20 cups per day. Budget cost per cup is 50 cents. So total cost is $500. Now they decided to check this lemonade project is how it is going. At the end of day 10, they have decided to check how the progress of the project is going. They checked, 100 cups have been made. Total actual cost is $90. So far they spent $90. Total cup they have made 150, and this is a day number 10. Based on that, you can understand planned value, actual cost, and earned value. Now look into that. By the day 10, it should be done how much? 10 days into 20 cups per day into 50, how much? So this is $100. Actual, this is the planned one that by this time it should be planned value is $100. Earned value, because you made, so far 150 cups are made, cost is 50, that earned value is $75. So this is earned value, and actual cost, how much? Actual cost is 90. So you know all three numbers. Now schedule variance, this is a formula which is this minus this, which is minus 25. So schedule performance index equal to this divided by this, which is 0.75. 0.75. So this divided by this. So which is 0.75. So you got schedule performance index. Now cost variance, how much? You earn so far $75. What is the $90 is spent so far? You have minus $15. So here you have minus $25. From planned, you have $15 extra spent. So cost performance index equal to this BCWP, which is this 100 divided by BCWP divided by ACWP. So which is 0.833. 90 divided by 70. So 75 divided by 90. So 75 divided by actual cost 90, which is 0.833. Once you understand these three numbers, now you are very easy to make your decision. So basically this is a actual cost, planned cost, and this is a CPI, cost performance. So $500 divided by CPI, so $600. What is the meaning? Means if the project keep going like this of making 1,000 lemonade, instead of $500, it is going to cost you $600. So you still only 10 days are completed. You have still 40 days. Make sure you do corrective actions in order to speed up the process, in order to save the cost. So within 40 days, you can minimize your losses, or you can make things within the budget. So project manager, they keep doing this activity on frequent basis, on weekly basis, on daily basis, monthly basis, as per the project size and the project requirement. So instead of 500, it is going to. Now schedule variance, it means how long it will take. So how many days? So 50 days is actually planned in 15 days to complete 1,000 lemonade. Schedule performance index is 75.75. Instead of 50 days, how many days? It is going to take 66.67 days. So it is going to take extra time, extra cost. And still you have 40 days. So being a project manager, you can do. So this is the simplest example to do it. Very simple calculation. And there are some project as some example I share, software project management. And you can do these some questions. So this is the earned value analysis, which is very simple. If you are able to figure it out, three numbers: actual cost, planned actual value, planned value, and earned value, you will be able to do simple calculation. So this is earned value analysis. But in Microsoft project, you get all detailed numbers. This is very simple. And being a project manager, on periodic basis, they use these techniques to understand, and they put extra resources. They tied the management, or they speed up the things. and they understand where is the problem, that's why delay. So they correct all the things in order to make project possible as close to as deadline and as close to as budget, allocated budget. So these are the two important methods. That is what I wanted to cover today. Any question, please feel free to ask. If you don't have, then I would like to say have a wonderful weekend, have a wonderful evening, and I will be there next week to answer all your questions. And next, how many, 7-8 days, I will be there to answer all the questions you will have. And thank you so much. Have a wonderful night and wonderful weekend. Bye-bye.